Welcome to Formula 1 Maths. This is sample exam questions 004 for the AQA Level 2 Further Maths course. We've got 3 questions to answer. Question 1. A circle with center 0, 0 has circumference 10 pi. Find the equation of the circle. B. Work out the equation of the straight line that is parallel to the line 2y equals to x and intersects the x-axis at 4, 0. 4a. The circumference of a circle is given by pi d or 2 pi r, where d is the diameter and r is the radius. So for this particular circle, the circumference is 10 pi. So we can equate 2 pi r to 10 pi to solve for r. And then rearrange it, we get r is equal to 10 pi over 2 pi. I can reduce a fraction. Pi goes there 1 and pi goes there 1. 2 goes there 1 and 2 goes there 5. That means r is 5. We also know that the equation of a circle is given by this formula, where a, b are the x and y coordinates respectively of the center, and r is the radius of the circle. So for this particular circle, the center is 0, 0. And now that we know the radius, we can go and do a substitution in this equation to obtain the following. If we simplify this, we are going to get x squared plus y squared equals to 25. And that is the equation of a circle. For B, the equation of a straight line is given by y is equals to mx plus c, where m is the gradient and c is a y-intercept. So I'm going to rewrite the equation of this line, 2y equals to x, in this form. It means I'm going to make y the subject. So if I do that, I'll get y equals to half x. This implies that this line here has gradient a half and y-intercept is 0. But the equation of the line that I'm looking for is parallel to this line here. That means it has the same gradient as this line. We have just established that the gradient of this line is a half. It means the gradient of the line I'm looking for is half as well. So I can go ahead and write the equation. So the equation of the line I'm looking for is given by y equals to half x plus c. I now need to find c to get the full equation of the line. I've got a point that the line passes through, and that is this point here, 4, 0. So this point must satisfy this equation. That means I can substitute these values into this equation to obtain c. So if I do that, I'm going to get 0 equals to half times 4 plus c. If I reduce the fraction, 2 goes there 1, 2 goes there 2. And I'm left with 0 is equal to 2 plus c. If I solve for c, I'm going to get c is equal to minus 2. I can now write the equation of the straight line as y is equal to half x minus 2. And that is the equation of the line. Question 2. Use the sine rule to work out the size of the obtuse angle x. The sine rule is given by this formula. So using this formula, I can see that sine x over 2y will be equal to sine 20 over y. I can rearrange to make sine x the subject. I can reduce the fraction by dividing numerator and denominator by y. And so I can cancel out this 1 and it goes there 1. And then I'm left with sine x is equal to 2 sine 20. And this evaluates to give us 0.68. So sine x is equal to 0.68. But we can find x by doing sine inverse of the whole of this. It's easier and more accurate than using this value here. So we'll put this in our calculator. And if we do that, we're going to get x is equal to 43.2. But this is an acute angle. And as you can see clearly here, we are looking for an obtuse angle. So what's the problem here? Let me draw this triangle again. So I get this. I'm going to make an extension of this diagram by drawing a line here and a line over there to get the following. And I've drawn that because this length is equal to this length. That makes this triangle here an isosceles triangle. So this length is y. Now we can see that this length, which is opposite this angle, the same length is opposite this angle here. And this length, which is y, which is opposite this angle here, is also the same length here, which happens to be opposite this angle here. So looking at a bigger triangle, the angle we found is the acute angle here. And so let's put that one in. And that is 43.2. And because this triangle is isosceles, with this side being equal to this side, it means this angle is also 43.2. So if I put that one in, that'll be 43.2. I can now find this angle, which will be x equals to 180 minus 43.2. So that will be the value we are looking for. But let me go and explain this further by drawing another diagram. So this is the sine curve. We know this is 0. This is 180. This is 90. This is 270. And this is 360. And we know the highest point here is 1. The lowest point here is minus 1. We got a value of 0.68, which will be somewhere over here. So let's put that one in there and draw a line across. Now, where this line intersects the curve are the solutions to this equation. So the first point will be 43.2. And by symmetry, this point here will be 180 minus 43.2. And so we get 136.8. And that's why this angle will be the same as this, which is 136.8. And so our final answer will be 136.8. These are the two explanations as to why this angle is 136.8 and not 43.2. Question 3. A, B, and C are points on a circle. Center O. Work out the size of the angle Y. So we are looking for this angle Y. We are going to use circle theorems. One of the circle theorems states that angles subtended at the center are twice the angle subtended at the circumference. Looking at the diagram carefully, this chord BC or this arc BC subtends an angle x plus 80 at the center. The same chord or arc subtends an angle 3x minus 60 at A, at the circumference. So according to this theorem, angle BOC is twice angle BAC. This means that if I multiply 3x minus 60 by 2, I must get x plus 80. So let's do that. So 2 times angle BAC is equal to angle BOC. We can now expand to get 6x minus 120 is equal to x plus 80. Rearrange to get 6x minus x equals to 80 plus 120. This will simplify to 5x equals to 200. And solving will give x equals to 40. So this means that angle BOC will be equals to 40 plus 80. And this will be equals to 120. So we are going to say this angle is 120 degrees. But BO is the radius of the circle. So is BOCO. That means this triangle BOC is an isosceles triangle with this side equals to this side. It also implies that angle Y, and the one we are looking for, is the same as angle OBC. So this is also Y. So Y plus 120 equals to 180. So we have 2y plus 120 equals to 180. Rearrange to get 2y is equals to 180 minus 120. This will give you y equals to 60 over 2, and that means y is equals to 30. So our final answer is y is equals to 30. And this is the end of this session of SEQ 004.